Hello everyone, welcome to the video. Today we are going to solve the problem longest common subsequence. In this problem, we are given two strings. We have to return the length of the subsequence which is common to both the strings and is also the longest. We are going to solve this problem today. If you are new to this channel, please don't forget to subscribe. Let's start. To begin with, let us first note down the key things given in the question. We are given that there are two strings and we have to return the length of the longest common subsequence. Note that we have to return the length and not the actual longest common subsequence. We are also given that both the strings are in uppercase letters. It is useful for us because now we don't have to deal with the confusion that whether capital A and small a are same or different. So if we consider this example, these are the two strings that we have been given. And the answer to this is 3. Why? Because the longest common subsequence in both the strings is A, D and H, which is of length 3. So if we consider our solution as a black box, we are getting two strings as an input and we have to return the length, which is an integer. So what will our function signature look like? Our function signature will look something like this. Before even attempting the problem, let us first try to understand what is a subsequence. From the example given here, what can we infer? The first thing that we can infer is that subsequence is basically some sequence of characters from the given string. What else can we infer? We can see that the characters in the subsequence are in the order in which they are present in the same string. Example, AB is a subsequence, but BA is not. The third thing that we can infer is that these characters that we pick, they may not necessarily be contiguous. For example, AC is also a valid subsequence. These three conditions together applied on a string will give us the definition of a subsequence. In our problem, our aim is to find the longest common subsequence between the two strings. So what can be the simplest method that we can think of? We can get all the subsequences of S1 and put them in a set of string. Similarly, we can get all possible subsequences of S2 and put them in another set of string. Then we can iterate over all the subsequences of S1. And in every iteration, we can just check if this subsequence is present in S2. If it is, our condition of common is satisfied. Then we just keep track of the longest subsequence that we have seen so far. And once we are done with all the iterations, we return the longest subsequence that we saw. Now, our problem remains that how do we get all subsequences of a string? We have solved this in the past videos with two approaches, backtracking and recursion. You can find the link to those videos in the description and also on the top right corner of your video. So, this is the way in which we can solve the longest common subsequence in simplest manner. But what will be the time complexity of this solution? From the previous videos, we know that getting all subsequences of a string takes exponential time. So the time complexity of this overall will also be exponential. This is really bad and we need to do something better. Now, we know that our simplest approach was a bit inefficient. So let's now try to solve this problem using recursion. Now what does recursion would mean? That means we will have to break this problem down into smaller but similar problems. Now what do we mean by smaller problem? Smaller problem means that the input will get smaller. Now what is the input here? The two strings. So the smaller problem would mean that the length of one or both of the strings will shrink a bit. So let's see. So this is our current input. Now how can we go to just smaller problem than this? This encircled area can be my just smaller problem. Why? Because I have reduced the size of just one of the strings by just 1, which is the minimum I can do. Now, if somebody tells me answer to this problem, can I use this answer to get the answer to my bigger problem? Let's say somebody tells me that the length of the longest common subsequence between these two strings is m, then what will be the answer to my bigger problem? It will also be m. So what we have done here is we have used the answer of smaller problem to get the answer of bigger problem. We didn't care how did we get the answer to smaller problem. We were just wondering whether we can use this answer to get the answer to our bigger problem. But this was just one way of going to the just smaller problem. Another way of going to the next smaller problem is I shrink the string 1 instead of string 2. Now if somebody tells me the answer to this smaller problem is n, then what will be the answer to this the bigger problem? The answer to the bigger problem will be n. But now what do I give the answer out of m and n for the two strings? Since I have to get the longest, I will get the maximum of the two. We still have one more case left. The case where we have to shrink both the strings by one character. What will be such a case? It will be when last characters of both the strings are same. In our example, last characters of both the strings were different. But if we had last characters as same, let's say we had x at the end of both the strings, then whatever will be the answer to this smaller problem, we will always add x to that longest common subsequence and our answer will become O plus 1. So if the answer to smaller problem is O, because of this x, our answer to the bigger problem will become O plus 1. So if there is a last character which is same in both the strings, we will have this as the answer. And if the last character is not same, we will have max of these two as the answers. So now we have seen how we can use the answers to smaller problems to find answer to the bigger problem. And that is the crux of a recursive relation. Let's see how can we now represent the smaller problems and the bigger problem as inputs to one single method call that will be called recursively. Let's say we have two pointers I and j that point to the end of both the strings, from where we are shrinking the string one by one. Now we can represent this bigger problem as LCS S1, S2, I and j to represent the end of the strings. Then how will we represent this smaller problem? LCS S1, S2, I and then j minus 1. Similarly, this one will be LCS S1, S2, I minus 1 and then j. And while this one will be LCS S1, S2, I minus 1, j minus 1. So what will be the answer in terms of these? It will either be maximum of these two, x comma y, or z plus 1, depending on whether the last characters of S1 and S2 are same or not. This is our recursive relation. Now with these in mind, let's try to write the algorithm for it. This is the recursive relation that we identified from the previous step. Now in any recursion problem, we follow these 5 steps. So the step 1 of identifying recursive relation is already done. We have also already identified the inputs that will go into the recursive method call. Using these inputs, we can represent the bigger problem as well as our smaller problems and the relation between the two. Now with these in mind, let us try to write the core of our recursion algorithm, and then we will move to the next steps. So from our main method, we will be calling this LCS util method with the inputs as S1, S2, I and j. I and j to begin with will be the last indices of the strings given to us. It is very common to often use a separate method that has to be called recursively than the main method that you have to solve. Now with these in mind, we will first check that whether the last characters of the two strings are equal. If they are equal, then we have to return the z plus 1. So we calculate z using this and return z plus 1. If they are not equal, then we calculate x using the same method call but with different input, and similarly we calculate y using same method call with different input, and we return the max of the two. Now this is the core of the recursive relation that we have written. But now is this algorithm complete? No. Why? Because this method is calling itself and it will keep on calling itself in every call. So this will go into an infinite recursion. This will never end. So how will we end it? To end it, we need to add base or terminating condition, our step 3. Now where do we get our base or terminating condition? When our input is smallest. Our input here represents that the relevant part of string S1 is still position I and relevant part of string S2 is still position J. So what will the smallest input mean? Smallest input would mean that relevant part of either of these strings becomes almost empty. And what does empty relevant part mean in terms of I and J? It means either our I has reached -1 or J has reached -1. Note that this is not 0 because if I is 0, that means there is at least one character in that relevant part of the string. So when either of these become -1, that means the relevant part of either of the string is empty. And what will be the longest common subsequence when one of the strings or one of the relevant parts is empty? It will be 0. This summarizes our base condition. And now our algorithm is complete and will work fine. But this is very inefficient because it has a lot of overlapping problems. Our step 4. How does it have lot of overlapping problems? Let's see. If we started with this input, let's say initial I and J were 6 and 6, then to solve for X, we will have to solve for 6 and 5. For Y, we'll have to solve for 5 and 6. And similarly, we can solve for X and Y for this and for this as well. Then we'll see that there will come a time when we will have to solve for 5 and 5 twice, once in this tree and once in this tree. Now this is just a small input size. If this input size was large and we had drawn the full tree, then we would see that the number of such overlapping problems will become huge. And every overlapping problem we'll have to solve multiple times. This is hugely inefficient. So what do we do about it? We can do one thing, that whenever we encounter first problem, we store its answer somewhere. And whenever we encounter the same input again, we don't calculate it completely again. Instead, we just look for it in our storage and return the answer directly. Now, what data structure will serve this purpose best, that can give us an answer for an input as quickly as we want? It will be map. So what information do we want to store here? We want to store that, hey, for this pair of I and J, the answer was this. So what will be the data type of value of map? Answer will be integer, the length of longest common subsequence. So value can be of integer type. And what should be the data type of key? Our key should be able to represent both I and J. So we can use string to represent I and J. How? We can combine I and J into a string like that. So this will be unique for a combination of I and J. So with this map, how will our now algorithm look like? Now we will have one more input to this function, map, of string and integer. Here, before returning the answers, we will put them in the map against the key. And how will we form the key? Key will be simply I_j. And before calculation, we will first check in the map if this key exists. If this key exists, that means we have seen this input before and we have calculated for it before. So we return the answer directly. This is our complete top-down dynamic programming algorithm. Now what will be the time complexity of this algorithm? We can see that we would have calculated the values for every combination of I and J possible. And for every combination, we would have calculated exactly once. So our time complexity will become big O of length of string 1 multiplied by length of string 2. The same will be our space complexity. Let us now go through the code for the same algorithm that we just discussed. You can also find the link to this code in the description. So here we are given the input S1 and S2 and also the lengths of the two inputs. So first of all, we declare our map of string and integer as key and value. Then we call our recursive method with initial values. Initial values of I and j will be x minus 1 and y minus 1. Map will be empty. Let's now see how does this recursive method function. So here in the recursive method, first of all we check the base conditions. The base conditions are when I or j, either of them reach minus 1. This means that either of the relevant part of the two strings has become empty. If that's the case, then there cannot be any subsequence, any common subsequence, so we return 0. Next, we build the key using I and j. Key will be used in the map. How do we build the key? We simply concatenate I underscore and j. Now, with this key, we first check in the map if we have already seen this input. If we have, we directly return the answer from the map. Otherwise, we check for the two characters at the end of both the strings. If they are equal, then we first calculate z and then we return z plus 1, but before returning, we put the answer in the map. Otherwise, we calculate our x or we calculate our y, then we get the answer by max of the two, and before returning that, we put that answer also in the map. And finally, this result is returned from the main function. This is it for this video. In the next video, we will go through the bottom-up dynamic programming approach for the same problem. We will also do a further space optimization on the bottom-up approach. If this video helped you in any manner, please let us know by commenting below. Also, don't forget to like the video and subscribe to the channel. We will meet again in the next video. Thanks for watching.